This question says, what is the difference between the largest and the second largest odd factor of 2016? So you're looking at the number 2016, and you're looking at the factors of 2016. And amongst all the factors, you're looking for the odd factors, those factors which are odd numbers. And then you take the largest of those odd factors, right? And then you take the second largest of the odd factors. And the question is, what is their difference? So in other words, what you have to do is to find the odd factors of 2016. But to find the odd factors, you might as well find all the factors, right? And to do that, you'll have to factorize this. So you factorize 2016. I like factorizing like this. I just put an equal sign, and I see that it's a multiple of 4 because the last two digits is a multiple of 4. So I take the 4 out, and you see the other factor is this. This is also a multiple of 4. You can see that the last digit, 2 digits, is 4. So I've got the 4 there times, and this is 4. Goes exactly into that. It goes 126 times. Right now, there's a 2 here, not 4 anymore, because it's 26. And you got 4 times 4, and this is 2 times 63, right? And now you group together all the even factors, because you got 4 times 4 times 2, right? That is 32, which is 2 to the power of 5, multiplied by 63. I'm just going to leave the 63 as it is, because that's an odd number. So now the question is, what are the odd factors? The question is, what are the odd factors of this? And the answer to that question, the odd factors cannot contain a 2 in it. You know, the factors of this number here are a factor of this times a factor of that. But if you're looking for the odd factors, it must not have any 2's in it. So you look at only the factors of this, right? So the odd factors are precisely the factors of 63. And you are looking now for the largest and the second largest odd factor. Right? The largest is 63, obviously. The largest factor of 63 is 63. And the second largest factor is this is 9 times 7. So you have to divide this by 3 to get this. So this is 3 times 21. And this is evidently the second largest factor. And the question is, what is the difference between these largest and the second largest? And the answer is 42. Problem 404 tells you if a plus b is equal to 6 and ab is equal to 4, determine a to the 4th plus b to the 4th. In other words, you are given the sum of two numbers, a plus b, and you're given the product, which is ab, and you're asked to calculate the sum of the 4th powers of a and b. Now, this is a long way from there, and one may wonder, how are you going to use information like this? But we have to go step by step, because we do know that we can actually calculate a squared plus b squared. Why? Because if you square this term, you will have a squared plus b squared coming out, and there is also an ab term in the middle. So let's do that, and we have done it here. A plus b all squared is equal to this. So a squared plus b squared, this part here, is actually equal to a plus b all squared minus 2ab. And we know what a plus b is, so that's not a problem, because that is given as 6, yeah? So this is 6 squared minus ab is 4, so twice ab is 8, and 36 minus 28, 8. 36 minus 8 is 28. It's 28. Right. So now we have a squared plus b squared. Now to get to a to the 4th plus b to the 4th, you perform the same trick. Because if you square this, then you are going to get a to the fourth plus b to the fourth in that expansion, but there will be a middle term. So let's do exactly that. A squared plus b squared, we squared it, and you get a to the fourth plus b to the fourth, and this is the middle term, 2 times a squared times b squared, all right? And then you can make a to the fourth plus b to the fourth the subject of the formula, and that is equal to this quantity here minus this quantity here if you take it to the other side. We already have a squared plus b squared, which is 28. So this is 28 squared minus, and 2 a squared plus b squared. A squared b squared is really ab all squared. So it's minus 2, and ab is 4. So it's 4 squared. Right? And if you work this thing out, you get 784 minus 32, you get 752. And that is the answer to the question. What is a to the fourth plus b to the fourth? Before we proceed to the next problem, I just want to point out certain facts about digits and numbers. If you have a 2-digit number, right? So you got 2 digits. So you have a first digit like 35. First is 3, and that is 5, right? This is actually equal to 3 times 10 plus 5. This is the tens unit, okay? So if you have, generally, if you have a 2-digit number, you can say AB is equal to 10 times A. This is the tens unit, 10 times that, plus B. Remember, A and B are digits. They are numbers from 0 to 9. 0, 1, 2, 3, 4. There are only 10 possibilities for A and B. But if A is a 2-digit number, then A cannot be 0, right? Because that would not make it a 2-digit number. So A will have to be either 1, 2, 3, or up to 9. So bear that in mind. And likewise, if you have a 3-digit number, A, B, C, A is a hundredth digit, B is the 10th digit, and this is C, like 356, for instance, is 300 plus 50 plus 6, which is 100 times 3, there it is, 100 times A, plus 10 times B, 10 times 5, which is 10B, plus C. So this is the general way of writing a 2-digit number and a 3-digit number. And you can extend this to other larger digits. The only problem is AB, when you write down AB, it looks as if you're taking the product of these two. So this is not a very good way of writing a 2-digit number. So we have a way of writing it. When you put square brackets like this, it means we're referring to the 2-digit number. Like here, 30. This is really the number 35. It's not a product, it's 35. And here we are saying the first digit is 3 and the second digit is 5. So those are some of the important facts you have to know if you want to do the next problem. So let's get straight to that problem. Okay, so the problem says the sum of certain integers is found to be 2,643. So what are we doing? We're adding a number of numbers, and the sum of all those numbers is 2643. It was discovered later that the digits of one of the 3-digit numbers in the sum was reversed. What does that mean? It is saying that I was adding a number of numbers, maybe 25 plus 397 plus 416 or something like that. And you're adding a number of numbers, and eventually you got 2643. And then you found, hey, wait a minute, I should have had 793 here. One of the numbers was reversed, right? And this should have been the correct one. And all the others are say the same. So the question is now, which of the following is a possible correct sum? So what is this? So the thing is, we don't know what these numbers are. We don't know how many numbers there are also. So there's very little information given here, apart from the fact that one of the numbers, the digits are reversed and you're getting the wrong sum. So the way to do this is you'll say, according to this now, they say the 3-digit numbers in the sum was reversed. I should have had that. This is not a product. That number instead of CBA. So in other words, I should have had CBA, but I wrote down ABC backwards instead. So this CBA, this 3-digit number would have given the correct sum. So when I look at this, of course, as I said earlier on, this is the value of this is 100C. This is in the 100th unit plus 10B plus A. So this is the actual value of this 3-digit number. And let this be the correct one. Because it says here that this is the correct one, this is the incorrect one, the reversed one. Okay. But what happened was we added the incorrect one and we took all the sum of the correct numbers. You see, like these are 25, 416, and so on. The sum of the correct numbers. That one was 2643, and we discovered that this was the incorrect sum, right? So, but we don't know what the correct sum is. So let's give it a name to this. The question is, which of the following is the correct sum? So let's give a name to the correct sum. So if you think about it, S is equal to the corrected one. In other words, the numbers, not ABC, but CBA, but plus the sum of the other numbers. And these sums are exactly the same, right? Because nothing happened to those numbers. All right, so now you have these two situations, right? And the problem is to find S. What is S? They give you that S is going to be one of these numbers. Now, how do you know which one of these is S? So let's have a look at these two equations which I've got in red here. I see that I got sum of correct numbers there, and I also got sum of correct numbers here. So if I subtract these two, then this sum here will disappear because you got the same number on both cases. Let's subtract them. I'll make S minus 2643. Right? What is that equal to? It's equal to CBA. This thing here, CBA minus ABC. Right? S minus that equals this minus that. And then if you subtract these two, it can become 0 because it's the same thing. So S minus 2643 gives you this. Now let's try to simplify this. So what do we have? We have CBA minus ABC. I've got CBA here. It's actually equal to this. So when you work out that, you get this minus this. So let's subtract straight away. You'll get 100 into C minus A. I'm looking at CBA minus ABC. 100 into C minus A. 10B minus 10B. Okay, that's 0. And then you get plus A minus C. That minus that. Now you got 100C. If you expand this, you get 100C minus C, which is 99C. And here you got minus 100A plus A, so that becomes minus 99A. And you see that 99 is a common factor. You take it out. So what does this say? It says that S minus 2643 is equal to 99 into C minus A. I don't know what C and A are. I don't know that. But I do know that this is product of two numbers, one of which is 99, and the other is this. All right. So in other words, 99 is a factor of S minus 2643. So we know the possible values for S. There are 5 possible values. And we subtract from each of these, you subtract 2643, right? And these are the 5 possible values for S. and I'm working out the left-hand side, and I get these 5 numbers here. But I need to look for the number which is a multiple of 99. This is not a multiple of 99. That is not a multiple of 99. Yes, this is. That is not. That is not. So the answer, so this is the correct one, right? And the S that corresponds to this is 2742. One of these gives the correct answer, and it's that one. So the answer to the question is 2742. The next problem states, if we place a 3 at both ends of a number, okay, so if you have some number like 4, 5, 8, and if you place a 3 on both ends of the number, like that, its value is increased. That means the original number was 458, and we created this new number, and the value now is increased. This original value is increased by, so you have to subtract these two, and you are given that this is 3372. Well, obviously, this would not work, but we are saying, we're trying to explain what's going on. So you have some number, right? Like this, you got a 3-digit number, and the same 3-digit number in this example, and you subtract it, you're going to get 3372. Right? So we don't know how many digits this number has got, right? And the first thing to do is the question is to find the original number. So the first thing to do is to see how many digits it's got. If you try, if you say, suppose the number was a 1-digit number, so you got a 1-digit number, you put 3 on either side and subtract that 1 digit, your answer will be a number like 300 and something minus a single digit, and you can never get 3372, right? So if you had a 1-digit number, you can never get 3372. Now, likewise, if you started off with a 3-digit number, right, like what we had there, and you subtract the same 3-digit number from this with the 3 is written on both sides, your final answer, you can see you only got 3 digits here, you got 5 digits here. And if you subtract these two, you're going to get a 5-digit number. And that cannot be equal to 3372 because this is a 4-digit number. So 1-digit number, it's not a 1-digit number. It's not a 3-digit number. So it must have been a 2-digit number, right? So X is a 2-digit number. So what we can do is we can say let X be equal to the 2-digit number. You can make it like that, 2-digit number. And we know the value is 10A plus B. All right. So what do we have? We have that this number here, the 4-digit number, 3, and you got this 2-digit number. Originally, you had that number in between, right? And you got 3 on both sides, and you subtract the original number. And the answer is 3372. So the problem is to calculate X. Right? In other words, what is the original number? Right? So X is that's the number that we're looking for. Right. So this is the thing we have here. Now this is a 4-digit number. So you got 3 is in the 1000th digit. The A is in the 100th digit. The B is in the 10th unit. And you got 3. That's that thing there expanded. And here you've got a 2-digit number. This is AB. The value of that is 10A plus B. And that is equal to 3372. All right. Now you can group together the A's and group together the numbers and so on. And eventually you'll end up with, the whole thing simplifies to 90A plus 9B is equal to 369. Right? When you put all the A's and the B's together and the number, and this is the same as 10A plus B. If you divide by 9 right throughout, because this 9 goes into this exactly, it's 9 times 41. You can see the sum of the digits is 18. So 9 goes into this. So you can divide by 9 right throughout. And 10A plus B is precisely the number X that you're looking for. So the answer is 41. This question says, note that 39 is equal to 3 times 9. Okay, first digit times the second digit is 27. You're multiplying them. And you're adding 3 and you're adding 9. So 3 plus 9 is 12. 27 plus 12 is precisely 39. So what we are saying here is that 39 has got the property that the product of its digits plus the sum of its digits is equal to the number itself, right? So 39 has got the property that the product of the digits plus the sum of the digits is equal to the original number. So the first question is find all two-digit numbers that are equal to the product of the digits plus the sum of digits. I find all. So one of them is 39, right? So can we find the whole lot? What are all those numbers? So we'll say the way to do this is we don't know what the number is. So let the number be 10A plus B. So it's a two-digit number. We are saying the first digit is A, the second digit is B, and the actual value of that, the two-digit number is 10A plus B. So what are we saying here? We are saying that your number, your two-digit number, that's your 39, is equal to the product of the two digits, that's AB, A times B, plus A plus B. Now, bear in mind that this thing here is nothing else but 10A plus B. All right. Now, you got a nice little equation here. The B is cancelled. And you got 10A minus A is A, 9A. And if you take out the A as a factor, you're going to get this. So A into 9 minus B equals 0. All right, you can check this thing out. So now you got the given information says, right? And I have a random number here. I don't know what A and B are, and I'm trying to calculate this A and B. And I get a nice little equation which says that the product of A, which is the first digit, times 9 minus B is 0. Now, when the product of two numbers is 0, one of them is necessarily 0. But which one is 0? Is A 0? Now, I'll tell you that A cannot be 0 because then it will mean that this A here is 0 and it cannot be a two-digit number. For a two-digit number, you must have A, B, but A cannot be 0. A starts with, A is at least 1, right? So A is not 0. Right? The answer is no. So therefore, if the product of these two is 0 and A is not equal to 0, so it means the other one is forced to be 0. So B is necessarily 9. So the only thing we can conclude is that the second digit, your unit digit, is 9. And they ask you to find all the two-digit numbers that are equal, would satisfy this property. So you look at all the two-digit numbers whose unit digit is 9. So there they are. Unit digit is 9. It could be 19, 29, and so on all the way. So there are quite a few answers. In fact, there are 9 such numbers. And you'll see that one of them is 39. There it is. Right? But all the other numbers, if you try it out, you'll see that all of them got this property. All right, so the answer to this question is that there are quite a few of those numbers. Right. Now, the next one, find all three-digit numbers having the same property. Right. In other words, you now are looking at a three-digit number. Yeah, and that, of course, is 100A plus 10B plus C, as we have seen earlier. Right? So suppose this is such a number. we need to find A, B, and C, as we did before. Right. Okay, so what property does this have? This number has got the property that this is equal to the product of the digits, right? A times B times C, plus the sum of the digits. So this is what we've got here. Your original number, 100A plus 10B plus C, right, is equal to the product of the digits, which is A, B, C, plus A plus B plus C, and that's the sum of the digits, right? So you have a nice equation, which is similar to the previous one. So when you calculate this, what do you have? You have the C's cancel, right? And you have 100A minus A is 99A. And then you got 10B minus B. 100A minus A. And 10B minus B is 9B. And that is equal to ABC. Okay. Now, the question is, where do we proceed from here? You might want to be tempted to take out the 9 and so on and argue the case out. You can try various things, but it doesn't seem to be getting anywhere. But there is a way out of this to find the solutions. What you do is you bring the ABC to this side and take the 9B to the other side, and you pick AB to this side, and you get A into 99 minus BC. When you bring 99A minus ABC and take out A as a common factor. Right. And now you got this. Now the question is, now can we solve for A? What are the solutions for A, B, and C? But you'll notice here that B and C are digits, right? The highest possible value that this can have is 81. Because B and C are digits. They could be both 9, right? So 99 minus this is always a positive number. Because this quantity is always smaller than 99. Its highest value is 81. And A, of course, is also a positive number. So you got the product of two positive numbers is equal to this. And this is impossible because B is also a positive number, right? So you got the left-hand side is positive, but the right-hand side is negative. And this is impossible. You can't have a positive number equal to a negative number, right? Which means that there are no solutions. That's the conclusion. You cannot find A, B, and C. So the answer to B is find all 3-digit numbers having the same property. The answer is that there are no such numbers, right? No solutions.